All right. Hi, everybody. I'm Jake. I'm the head of the Quay project at CoreOS. And this is Quentin. Quentin is a software engineer at CoreOS. We're going to tell you a little bit about Clair, which is the container image security analyzer. And we're going to tell you a little bit about what it does. But quick question, who's actually heard about Clair before? The right half of the room. I don't know why you guys self-assembled that way, but all right. And who knows what CoreOS does? Who's heard us speak about anything before? Us, Quentin, and I personally. Yeah, OK. All right, cool. So I don't need a second view. So what CoreOS does is our tagline or our marketing pitch is that we're running the world's containers. That means that we're developing parts of the stack all the way from the base operating system itself all the way up to helping work on Kubernetes alongside Google, developing the cluster managers, developing these higher level things like Clair and Quay that facilitate using containers in your infrastructure. We have over 90 open source projects on GitHub. We just open sourced one today, so that's 91 now, or 91 plus. And we offer some enterprise solutions to really wrap all these open source components that are core to what the company does. We wrap them all up, put a nice little bow on it, and charge for support. Standard open source model. Additionally, I always forget to mention we're hiring in all departments in Berlin, SF, and here in New York for all roles from marketing, back-end, front-end, everything. OK. So this is Quay. Have any of you guys used Quay before? I know you've heard me talk about it, but you haven't used it. All right. So Quay is our container image registry. It's the place where all of your built deployable artifacts land before you ship them off to your production servers and before you end up running them. This is a picture of a particular repository on Quay. This one's kind of interesting because it's the etcd repository, which I swear someone has a script which pulls it every second and a half or something. So in the last 30 days, there have been 2.6 million pulls of this image alone. And in the last 24 hours, there have been 186,000 pulls. I believe these screenshots were regenerated today, so this information is accurate. But this is basically where we store our deployable container artifacts. And so what does that mean? A long time ago, you used to have an ops team. And the ops team was responsible for picking the operating system that got deployed to a particular server that was running in your infrastructure, as well as a common set of dependencies that all of the things that you would deploy to those servers relied on. So this would include your specific versions of Python, your specific versions of Java, the vetted version of Nginx that wasn't susceptible to horrible bug of the day. And then the app developers would go and they would use this known set of version dependencies, and they would develop their code against it. And when you wanted to rev the version of Python, or when you wanted to have two different versions of Java on one box, it became a nightmare for everybody involved. So this is what we call the ops dev clash. You have the dev team that's saying, I need the latest version of Python at all times. I need the latest version of dependency A. And the ops team saying, I can't keep up with your crazy requests. Or no, you can't have that. That's crazy talk. That's only been out for 16 hours, and it's in alpha. I'm definitely not putting that on our production boxes. So this was a source of a lot of friction. Along came containers, and containers fixed this for everybody, right? So I don't know if you can see, but the line where we draw what was previously the role of ops and the line of what's now the role of devs has shifted to the left of the dependencies. So everything in blue, devs are now responsible for. Everything in red, still the ops team. And additionally, there's a gray box around the app and its dependency. So this means that we've really moved the problem, and we've given the developers the flexibility to pick the version of the dependency that they want to actually use. So this means on a single box, we can have different versions of Java, different versions of Python. Everybody's happy. The dev that's building staging service A gets to use their bleeding edge library, and they get to bake it and see how it works. And they don't impact the other people who are using more stable stuff. And of course, the ops team is happy because they don't have to manage any of this stuff, right? The ops team is happy? Not really. So one of the first problems that we find is that it's not often as nicely packed as we want to think. So yeah, sure, I just throw a version of Python in there, but what does that actually require itself? Or maybe I use a base image that actually contains an entire operating system itself. So these things end up being much fatter than, if you buy into the container hype, they end up being much fatter than what the original container vision enveloped. So here we've got a container which contains basically an entire operating system's dependencies and then layers an app on top of that. This is, we have concrete data on it. This is the way that the majority of containers are built today. Finally, there are specific base images that your users will pull in that you don't even know what's in there, right? So we have the etcd-git repository, which we can put for appc, which is built on the Golang base image that comes from the Docker Hub and is essentially built and mysteriously pushed into Docker Hub. And we, without opening that thing up and inspecting it every time, even we don't really know what's in it, even though it's a dependency of ours. So here we have our spooky forest, okay? Who knows what this is? Ghost, yes. So Ghost is the nickname for CVE 2015-0235. It's a horrible, horrible, horrible bug that affects the get host by name functions. This is not something that you want to be shipping into production. I'd like to say that I think 2013, 2014 was around the time when CVEs got like so exciting that we started giving them avatars. How about this one? Who knows what this one is? Everybody knows what Heartbleed is. So CVE 2014-0160. This is actually probably the first CVE that I can think of that has a logo with blood coming out of it, but there have been many that have followed. So Heartbleed essentially exposed your SSL private keys to the world. Not great. Everybody in this room probably had a really harrowing day where they went and rotated all of their SSL private keys. Fun times. So how do we know now that we've bundled all of these dependencies, such as OpenSSL, which is the dependency that actually had Heartbleed in it? Now that we've bundled these things into our deployable artifacts, how do we know that our containers actually have these vulnerabilities, and how can we audit that? Just another scary statistic. I believe this is 76,000 vulnerabilities that we're tracking in the Clair database. Is that correct? Or is that the whole NVD? It's the NVD database. Okay, so this is such an important problem that there's a national vulnerability database that keeps track of this stuff and says, like, these are the things that you need to worry about. So I'd like to point out that we showed 2 that are named. What about the other 75,998 vulnerabilities? How can you keep track of whether you're susceptible to them and whether you need to go do anything to patch them? Right, so we need to answer the question, right? We've moved the dependencies from the operating system into the containers, and this is actually part of the core pitch of CoreOS. So CoreOS is a minimal Linux operating system that doesn't really ship very many dependencies. And we're saying, look, now it's secure because we didn't ship any dependencies. But everybody put them in their containers, and they're still on the box. So we needed to fix this. We needed to make it better. So what did we do? This is a super critical project that required a lot of code, so we gave it to an intern. So Quentin came on to CoreOS, and he was like, so what am I going to work on? And we're like, I don't know, probably something super important. You seem like a really smart guy. So we kicked off the Clair project. Within 2 weeks, we had a demo, and then we haven't looked back from there. We've continued to improve it, and we just released Clair 1.0, what was it, last month? Yeah, not too long ago. And with that, I'm going to transfer the mic over to Quentin, and he's going to tell you a little bit about the saga of turning Clair into a service and running it.
All right. Hi, everyone. So before explaining how this thing works, I'm going to actually show you a little demo. This is our integration with Quay. So when I was preparing the slides, I found an interesting Nginx container image. So this is publicly available on the internet, and I just found it, and I thought this image was quite interesting. So let's say I just wanted to deploy a web server. I would use this image, right? So if we go to the tags page, actually we have our integration right here, and this thing says that this image may have over 100 high-level vulnerabilities. So let's click on this thing and learn more. All right. So here we have a full report that says that this image may have over 600 vulnerabilities, actually. To be fair, with 400 being fixable, that means that this image is probably kind of old, actually, old. If we scroll down, we can see a couple of vulnerabilities. So we have, for instance, this OpenSSL vulnerability, and we have some details such as the fact that it's exploitable on the network, it doesn't need authentication at all. We have a description as well. You may learn more on this link right here, which will bring you to the page of the actual vulnerability. If I have internet, I can learn more. Yeah, absolutely. So here, this is how Debian tracks that vulnerability. Right. So we also have some nice information. We know that this vulnerability affects OpenSSL and has been introduced in that container because this container has OpenSSL in version 1.0.1K1. But more interestingly, we can see that this vulnerability can be fixed by upgrading that packages to that version. So it's quite simple to fix. We also have the command that we need to rerun if we want to actually fix the container. But way more interestingly, in that image, there is something quite scary. Okay, so let me find it. This is a long list, like way too long. Oh yeah, that thing right here. What the hell? MySQL. I thought this image was only containing a web server, and it actually has MySQL. That's interesting. And this is a high variety. So yeah, are we sure that this container is minimal? I'm not sure anymore. Well, there is another thing that we can do on this integration, which I think is pretty cool. If I go back to that repository and I go to settings, I can create a notification. So here I can type a name. All right. So we select notify me when a package vulnerability is found. I'm interested only in high or medium, let's say, medium or higher vulnerabilities, and you should send me. You can select like Slack notification, email. I just set a quick notification for the purpose of this digital demo. Oh, I'm on prod. All right. So. Oh, I should do it on this thing, probably. All right, so I have this actually here, right here, so it's fine. Now, I will create a vulnerability in Clair manually. You should probably not do this, but I'm doing it. Right here, and I refresh the page. I actually have a notification on Quay telling me that my image contains a new vulnerability. So yeah, let's go back to the presentation. So now I'm going to explain to you how what you saw actually worked. I will go through 4 different points to describe Clair. The first point is that Clair does static analysis. So we've built Clair in the context of analyzing millions of container images. Running these containers can be pretty expensive. Running any of these containers is unsafe, right? We're actually scanning them for vulnerabilities, so they probably have vulnerabilities. We don't want to run them. We should probably nest them into like virtual machines or like use alternative stage 1 isolation mechanism if we want to run them. This is not great. Also, there are several dynamic analysis tools out there. They're pretty solid, but they all require human input. And at this scale, we don't want to add any human work there. We want everything to be automatic. So this is why we did static analysis. Second point is, now if we add to the context that over 50 new vulnerabilities are published each day, what happens when new vulnerabilities are published? Do we want to reanalyze every images? Probably not, right? So Clair tries to do everything only once. It does this by extracting and storing all the data it can possibly detect on an image. And because of the immutable nature of container images, we'll be able to use that data, cross-match that data now with the current set of vulnerabilities, but also in the future with the future known set of vulnerabilities. So this is pretty cool. Clair also pushed that forward, like even further by analyzing not only the images, but every single layer that composes images, and we store the data for each of them. That means that if multiple images, uses the same set or basically the same set of layers, we'll just be able to reuse what we analyzed before, and we won't need to reanalyze all the things that we've done before. The third point is about suggesting and notifying. I think I've shown you that pretty well in the demo. When developers look at the security report, they may feel helpless. So with Clair, we decided to be clever than that and try to give actionable items to the developers. So it's very easy for them to actually fix their containers. Once they feel pretty comfortable with their image, we don't want them to come back on these reports. We don't want them to go back on Quay or whatever registry may use Clair. So what we've done is making a notification system. So it means basically that Clair will tell the developers when new vulnerabilities are published and may affect their containers. The fourth point, and I think this is one of the most important ones, is that we've done Clair as a framework. Because Clair is open source, we've made it very extensible. Basically, it means that any developer may integrate their own behavior into Clair. This is a small diagram of Clair. I don't know if you can see anything, but here in blue we have the clients, and they discuss to Clair through the RESTful API. And that RESTful API is going to discuss either with content detectors in the case of an image analysis or directly with the data store. We also have notifiers right here, which are going to transmit any notifications to the clients. And finally, we have vulnerability updaters right here that are going to pull new vulnerabilities basically from external sources right here. So everything here in green are extendable. I'm going to discuss a bit about what does extendable means. So to extend any of this subsystem, you need to implement some interfaces. So that's the three interfaces for detectors. So what a detector is. First of all, we have a data detector, which is going to parse basically the image format. So it may be appc, it might be Docker, it might be OpenVZ, for instance. Then we have two other interfaces, feature detector, which is, I think, the most important one because it's going to detect basically everything on your image, which it could be like packages, that could be private keys, that could be basically anything. Finally, we have a namespace detector, and this is going to create a context around the features and the vulnerabilities. I will talk a bit more about this later. Then we have these two interfaces, vulnerability updater right here, which is simply going to ask external sources for vulnerability and return a set of vulnerabilities to Clair, so Clair can update its internal vulnerability database. And we have notifiers, which just take a notification and transmit them to a third party. Finally, we have a big interface right here, and this is our data store. This represents all the interaction between Clair and its database. So what does Clair currently support? Well, 2 image formats, appc and Docker, and then 3 main operating systems, Debian, Ubuntu, and CentOS. How detection is done with this for this operating system, this is package managers mainly. So this is dpkg, for instance, or RPM for CentOS. And they take their vulnerabilities directly from the distribution-specific vulnerability trackers. And this helps Clair be super accurate, actually, because the maintainers of the distribution know exactly which packages can be affected and which version can be affected and what are the actual fixed versions. Thanks to the namespaces, we can actually say that a particular vulnerability has been fixed by a backport in the operating system. So this is quite important. For the database, we support Postgres 9.4+. This is because we use recursive queries, and that make Clair very fast. And we support only webhook for notifications currently. So what's next? We would like to revisit our database implementation. Huawei wants to see MySQL support, for instance. We'd like to improve our release distribution. This is like basically shipping a single Clair binary instead of binary and, for instance, database migrations. We want to improve our client user experience. This is because initially we developed Clair for container registries. So Clair, you can only interact with Clair through its API, but a lot of people actually want to use a command line tool because they just want to analyze like local images. So there is a person from Humanity who is going to implement this. I saw the PR today actually. This is going to be pretty cool. We'd like to expand its detection capabilities. So this is, for instance, Alpine support, Alpine Linux. This is very important for us, but unfortunately, Alpine Linux does not provide any vulnerability database right now that are human readable, machine readable. It's only human readable, so it's not great. We'd like to implement stuff like NPM, Python, OS, or Ruby, even Ruby. And basically anything you'd like to see because it's open source. Sure.
So MySQL, is that either or support
Both.
I don't understand the question. Clair will only talk to one database at a given time?
No.
Yeah.
He said revisit, meaning you're going to support.
Oh, these are
No.
just things that we want to add
Yeah.
additional implementations of the interfaces for.
Yeah. So yeah, if you want to learn more about open source and cluster distribution, we invite you to come at CoreOS Fest on May 9th and 10th in Berlin, Germany. There is also a satellite event in San Francisco.
There's still tickets available. I just booked mine yesterday. I mean, plane tickets. I don't know.
Thanks, everybody.
Questions? You gotta have them.
Does that database that you're pulling from also have license information so it could tell me when I'm pulling a GPL thing by accident? That'd be really nice.
The vulnerability database doesn't.
Yeah.
I'm assuming that the package databases do. The ones for.
Right.
So you could do. The feature detector already understands what packages you have. So a feature in the context of a operating system namespace is a package. So if you made a vulnerability scanner which considered GPL v2 a vulnerability, you could match those two up and be notified. And this is actually a really important thing that we've had requests for. People are like, help protect me from myself. Don't necessarily protect me from other people.
Yeah.
One of the things I think is really cool is the notification model. And so it's a default webhook, and I can do whatever I want with that webhook. Because I'm thinking of like building a middleware layer where I can actually have it send that notification and then actually do the update on its own.
Absolutely, yeah. You could definitely do this.
People are certainly talking about it.
Yeah.
And there are, I won't call them competing solutions to Clair because they do dynamic analysis, but there are other people exploring this space that want to automatically patch things for you. As a container image registry, we don't know where your images are going. We don't know if they're hooked up to an auto-scaling group, for example, so we don't really want to mess with your container images that are currently stored on Quay. But you could certainly build something that consumes that webhook, does a thing, and then pushes back into Quay and fixes those things.
Yeah.
You basically have the context for knowing what resolution models you're willing to accept.
Yeah. This is not directly integrated into Quay, but with Clair, you can definitely do it.
Right. So he mentioned that the webhooks that come out of Clair are like just webhooks, but then those webhooks go into Quay, and then they can fan out into any of the webhook or any of the notification types that Quay supports, which also include webhooks. So we'll just turn around and send it to whomever. So like you can even use the Quay first-party integration without having to deploy your own Clair.
Oh, cool.
Are you looking into figuring out the version of Go that the binary was compiled with? Because the recent versions 1.6.0 and 1.5.3 of Go had an SSL vulnerability. Detecting that on its own is going to be tricky.
That is a super hard problem. We've talked about fingerprinting mechanics, which is essentially what you'd have to do, but there are no concrete plans to add that. Additionally, it's like if I vendor a piece, like if I vendor a dependency in Go, if we have enough information, like if we can look through the layers and find the things that you vendored at some point before you strip that information out, then maybe we can do something there, but it's super hard problem. That's like PhD level fingerprinting stuff. So. It's awesome background music.
Yeah.
Just understand, like, is this integrated with Quay, like not any other?
No, so I know this is integrated in other open source container registries, and I know this is also implemented in different companies internally.
So Clair itself is just a Go
Yeah.
project, like an open source Go project, and you can deploy it however you want. The only integration that we've built, first party integration, is the one with Quay.
Yeah.
Other people are building it for everything under the sun,
Mm.
building integrations.
So, is that part of CoreOS, or is more like a service on top of that?
Which one, Clair or Quay? Clair is just an open source project on GitHub. It lives in the CoreOS namespace, so it follows all of the contribution mechanisms that we have for other CoreOS open source stuff. But yeah, it's just an open source project. If you want to run it yourself, like
Yeah.
we run a Clair stack for Quay, so we take the open source project, we bundle it, we run it on our infrastructure. If you want to interface with that, you have to go through Quay. If you want to run your own Clair, it's up to you how to bundle it and run it. And we showed the list of databases and stuff that we support.
Quay is more like a registry.
Yeah, Quay is absolutely a registry. That's correct. We only analyze the images that actually go through Quay itself.
The Docker has a competing project called Nautilus, I believe. Do you know the differences that Quay and Clair, the combination, as opposed to?
I don't think there's actually any public information on what Nautilus actually is. What Docker has publicly said is that it will do dynamic analysis. It will run the containers, I believe. Yes, back me up. That's what they've said.
Yeah, we don't know much.
We don't know.
Yeah.
It's kind of a big question mark.
Wait and see, I guess.
It's a name right now. At some point, it'll be a product. Okay. All right, thanks.